Yes. The beauty of my PC crashing in the most inconvenient way. Such fun, such wonders, such beauty. Yes. God damn it, computer. Alright, well, my computer crashed. Which is always fun. Just always absolute fun. Fun. Anyways, where was I? So, I was explaining pointers and I was saying before I got rudely cut off by my computer. I was saying that if you want to make an integer pointer, you make if you want to create an integer pointer, you make an integer. Or sorry, if you want this pointer to point to an integer, you make it an integer pointer. If you want this pointer to point to a float, you make a float pointer, right? So this is a float pointer that points to a float variable, right? And so on and so forth. Okay, so I would like this integer pointer to point to phone number. How do I do that? Well, I can just do this, right? This won't work because this is an integer, right? An integer is holding a number, and a pointer can only hold a memory address. The pointer itself, inside the pointer, it can only hold this, right? It can only hold this. It can't hold 557788. So we need to point to the memory. We need to point to the memory address of phone number. How do we get the memory address of phone number? We use the AND symbol. So the AND symbol will give me the memory address of phone number. The memory address of phone number will be stored inside the pointer. And so now the pointer is pointing to the memory address of phone number. And so if I stdc out the pointer, you will see, and if I press play, you will see what's going to be printed is a memory address. It's a long string of memory address, of numbers, which is the memory address. And see, this is the memory address over here, right? So 000008B9E0FDD94, right? If I restart my application, you'll see that the pointer now is a different pointer, right? It's FDCC4. And that's, again, we talked about this. This is a security in all operating system where every time you run your application, you get a random memory address. You don't get the same memory address. So this is CC4. If I restart my application, that's going to give me 9B4, right? So this is the memory address. So now the pointer is holding a memory address. Okay, how can I check the value of phone number? Because this pointer points to phone number, memory address. But how can I actually see what's inside the phone number? Well, I can dereference this pointer. Dereferencing a pointer is putting a star before the pointer like this. This basically is dereferencing. Dereferencing means I'm going to go to this variable, right? So why am I doing this? 1 second. Un momento, señorita, por favor, or something along these lines. I think that's Spanish. Maybe. No idea. But it's fine. All right. So here's the pointer, right? This is a box. This is a box. Inside this box, and this is called the pointer, right? Inside this box, there's a memory address, 0x0015. Okay. There's a box somewhere else called phone number. Inside this box, there's a value 557788. This phone number also has a memory address of 0015. So notice the pointer is pointing, the value of the pointer is the memory address of phone number. So it's pointing here, right? This pointer is pointing over there. So what does dereferencing mean? When you put a star in front of the variable, that means it's dereferencing, meaning rather than without the star, I'll print the memory address. I'll print the contents of the pointer. That's without the star. With the star, I am going to print the contents of what I'm pointing to. In this case, it's 557788. So dereferencing means go to this memory address and give me the value inside this memory address. And so now if I press play, by dereferencing this pointer, I should see the value 557788. Which I do. So you can see now I'm printing 557788. So this, let me do the reference the pointer. Okay. And this is the pointer. So notice here, I'm printing the pointer, I'm printing the memory address right away. And here I'm dereferencing the pointer, meaning I'm getting the value of where the pointer points to. So the pointer points to phone number. Dereferencing means I don't want to see the phone number memory address, I want to see the value of phone number. So if I press play, you'll see that the pointer is just a pointer. It's going to print the pointer, right? This here is the pointer of the phone number, and when I dereference it, I actually get the value of the phone number, right? Which is over here. So those are pointers. That's how you use pointers, and that's how pointers work. And they're beautiful, absolutely beautiful. And hold on, I can prove this to you one more. So you can see here, this is, and I can do here, I'll say phone number member mem addr. Okay, I'm going to get the memory address. Okay, so here, okay, and then here I'm gonna say value of phone number. I'm gonna print phone number. Okay, let's look at this for a second. I'm printing the memory address, the and means the memory address. So I'm printing the memory address. Let me check my mic levels. Sorry, 1 second. Okay, it's 100. Good. Just want to make sure. Okay, so in here, I'm getting the memory address of phone number. All right, I'm printing the memory address of phone number. In here, I'm printing what this pointer holds. What does the pointer holds? The pointer holds the memory address of phone number. So these two numbers should be identical. The memory address of phone number and the pointer that points to the memory address of the phone number, both of these should be identical. Now, the second line here, I am dereferencing the pointer. So I'm dereferencing the pointer, which means this pointer is going to go to, like I said here, this pointer over here, right? It's going to go to this memory address, and it's going to print the value over here. That's what dereferencing means. And then I'm also printing the value of the phone number, which is the normal variable. So these should be identical, and these should be identical. So if I press play now, you'll see that phone number memory address is 0002945F8DC14. And it's the same thing, 2945F8DC18, right? So that's the pointer, and this is the phone number memory address. Here I'm dereferencing the pointer, and here I'm checking the value of the phone number. So both of these are the same value, which makes sense, right? So those are pointers. Pointers are important. They're essential in C++. We use them a lot. They're powerful. They point to stuff. And to be frank, who doesn't like to point to stuff? We all like to point to stuff all the time. All right, so I'm going to delete all this code now. So now the idea, and again, I explained this before, What I want to do now is make a table. Right, where's the table? It's gone, I guess. Make a table, right? So where my stuff are? Where my stuff at? Go away, please. So those are pointers. Now my objective, what I'm supposed to do is I'm gonna take this over here, and I am going to number every single tile with an index. So this is 0, 1, 2, 3, 4, and so on and so forth, right? This is 24, this is 25, 26, and so on and so forth, right? So to do that, I'm gonna make a tile class. The tile class will have an ID, will have a texture pointer, right, which points to this, and will have a sprite, right? And so for every single tile in here, right, every single tile, I'm gonna give it an ID, I'm gonna give it a texture, and I'm gonna give it a sprite. All right. Alrighty doodle. Alrighty doodle. Very beautiful. Very, very beautiful. Beautiful. Okay. I'm thinking here. I'm thinking, should the tile hold a sprite? I'm thinking, should the tile hold a sprite? Should the tile hold a sprite? Yes, it should. Okay, cool. All right, so let's do the work. Let's do the Lord's work. Whatever the Lord's work is. Anyways, if I press play now, have my program as is. I'm just turning a bunch of tiles next to each other, right? Okay. So what I need to do is create the tile class. And this tile class, I'm not gonna create a tile class. I'm only gonna create a header because all I need is the header. This tile class only contains data. It doesn't have any functionality. It doesn't have any functions, only data. Right, so I'm gonna make a tile.h class, and that's it. Nothing else. In here, I'm gonna create a struct. Called tile. The tile struct will have a SF texture. Let me include the SFML graphics thing here. So I'm gonna create a texture pointer, called texture. Gonna create a sprite, called sprite. The sprite doesn't have to be a pointer because every tile has a unique sprite, right? And I'm gonna create an integer ID, which is gonna have the value of -1. Okay, why did I do -1? Is because if I made it 0, right, the first tile is gonna have the value 0. Right, the first tile is gonna have the value 0. So if I make the ID 0, that means that every single tile all of them will point to here, right? If I forgot to assign, if I forgot to say ID equal to, I don't know, 25. If I forgot to do that, then by default all IDs are 0. And so it's really hard to debug later on. It's really hard to figure out what went wrong. Why is the ID like, because it looks valid. When I see 0, it looks valid. I know it's pointing over here. However, if I say it's -1 and I forget that I made this, if I forget to change the ID to 25 and I see -1, I know that, hey, hold the phone. -1 means it's not initialized. I never actually gave ID a value. It's just set to -1. There's some issue in my code, right? So when I see the -1, I get that idea in my head. However, when I see the 0, I'm like, okay, it's set to 0. 0 is the first tile. There's no problem here. right? And it takes me a longer time to figure out what's going on. But -1, it's obvious to me. Like, okay, -1, there's a problem. There's an issue, right? That's why I set it to -1. So I have an ID, I have a texture, and I have a sprite. Here is the thing. What the hell is a texture? So what the hell is a struct? We never used structs before. What is that? Well, a struct, ladies and gentlemen, is the exact same thing as a class. There is literally no difference. They are literally the same thing. Copy paste. A struct is the same thing as a class. Okay, that's a lie. A struct is the same thing as a class, with one notable exception. The default the default access for a class is private, meaning all these variables by default are private. Right? All these variables by default, they are private. However, by default, for a struct, all of these are public. That's the only fucking difference. That's it. Other than this is called a struct, this is called a class. This is the only difference. In C#, a struct and a class, they are different. A struct in C#, you're passing by value. A class, you're passing by reference. In here, doesn't matter. They're the same thing. The only difference is all these variables are by default, they're public, unless you set it to private. Unless you set them like this to private. By default, they're all public. In here, for a class, by default, all of these are private, unless you mark them public. So this is public by default. This is private by default. Only difference. Literally only difference. But usually, whenever you see the word struct, you programmers have this intuition, and they kind of put this unspoken rule. A struct is for only data. There are no functions. There are no methods. It's just data, right? A struct, just a bunch of data. Which is what this is, just a bunch of data, right? All right, I need to make sure to mark this as null pointer, PTR, just to always, and I always say, always initialize things to default values. And you might wonder, ask, why didn't you initialize an object to a default value? For objects, you don't need to. For pointers, you have to. For variables, you have to. For objects, the default constructor will be called. The constructor of the sprite, the default constructor, will be called for this, so I don't have to do anything here, right? All right, cool. Woo! Nice work. That's all I need to do for a tile. Woo! All right, let's go to a map. This is my map. Now, instead of making an array of sprites, I'm going to make an array of tiles, and I'm going to call them tiles. So to include tile, right? And I have an array of type tile. They're called tiles. So now I have 10 tiles, right? All right. So first thing that I need to do, it's gonna be called tiles now. Tiles. Well, all of these are wrong now, so just okay. So what do I need to do here? Well, first I need to load, right? I need to load. I'm loading the texture. I'm loading the appropriate texture. Now, when I load the appropriate texture, okay, I need to assign my tiles. I need to give my tiles a value. All right. Okay. So my tiles are going to be like this. I'm going to say tiles. I'm just going to for loop this. For 10 tiles at I dot texture equal to the memory address of this texture, right? Because remember, texture is a pointer, and it needs to point to the memory address of my tile texture, right? So that's done. So tile is now set. Next, tiles.id equal to I, right? Because every loop iteration, I is 0. So I'm going to set the ID to 0. and then the next tile is going to be 1, and the next tile is 2, and the next tile is 3, and so on and so forth, right? Now, for a sprite, I don't need to do anything for a sprite. Just keep it the way it is, right? All right, so we got all that covered. We have our loop here. But here's the thing. This tile texture is not... there aren't 10. There's 288, right? And the way I know that is because, remember, we did the math before here. We said total tiles x. I get the texture size, and they divide by the width. And same thing here. And so I need to set the tiles to these values, but I can't do that because I'm initializing the tiles here at the very beginning, at the very start, right? Okay. I really just want to do this. And I really kind of don't want to explain this, but I have to explain this. Damn it. All right, so more things to explain. Here's the problem I'm facing. You see tiles, 10. I'm creating an array of size 10 in here, but every time I load a texture, right? Every time I load a texture, I don't know how many tiles in this texture. There could be 10 tiles, 100 tiles, 50 tiles. I only know after I do this math, right? But by this time, it's too late. I already said that these tiles there are 10 tiles, and that's it. There are only 10 tiles. But in here, there are more, right? I know because I did this math. This is going to be 24. 24. That's going to be 12. So 24 by 12 is 288 tiles. So this array should say 288. But I don't know they're 288 until I do this math. If later on I decide to load a different tile sheet, right? I need to do this math. Like it's not like I know it by... It's not like I'm gonna know it. Like every tile is different, right? So, and the problem is I cannot change the size of the array. I cannot be like, hey, I can't say, hey, tiles now has the size of 288. I can't assign that later on. If I make an array, and if I set the size of the array, I do that once, right? However, while that is true, what I can do here, and this is special, what I can do is I can create a pointer called tiles, right? This is a pointer. This pointer is equal to new tiles, which is an array of 288 elements. Right? So now this is just a pointer which points to an array, where before I just made an array like this, and I could only set the array size in here when I create the array. But if I make a pointer and then I make the pointer points to the memory address of the array, which is an array that I choose the size of, this works fine. This works perfectly. So think of it as I am delaying the creation of the array. I'm not creating the array at line 10. I'm creating it at line 27 in the CPP file. And the way I can do that is by the power of a pointer. The array creation happens in this highlighted section. I want a new tile array which has 288 elements. And I cannot change that later on, right? Only 288 elements, right? This tile array, or this tiles, is just a pointer. It points to my array, right? Which is good. Okay. So now I can do that. What is the new keyword? Whenever you're allocating new memory, whenever you're allocating memory for a pointer, you use the new keyword, right? So essentially in memory, what I'm doing, this is what I'm doing, this is what I'm saying in memory. I'm saying this. Hey, give me a table, right? This is my memory. And I'm saying, please find me a place that has 288 elements. So let's say these three over here, these are all 288 elements. Let's, for argument's sake, let's say these are 288 elements. So whenever I say tiles equal new, I allocate memory and I say, hey, these are 288 elements. Okay, for a pointer. Now, you might wonder and ask, well, we never had to do, I still don't understand. Like, we never had to do this before. Like before, I made an array, right? And my array was just 10 elements, right? I didn't have to use the new keyword. Why all of a sudden I have to use the new keyword? Well, again, I'm using the new keyword because I need to allocate new memory for this pointer. This memory will be allocated on the heap. And I really didn't want to explain this now, but sure, why not? Let's explain it now. And you might remember before, somewhere before, can you open? So before, somewhere before, I explained the heap and the stack. Was it here? Or not explained it. I said I'll explain it later on. I mentioned the word heap and stack. Here we go, stack. So I said I'm going to talk about the stack later on. I'm going to talk about the heap later on, right? And this is the perfect time to talk about the stack and the heap. So what is the stack and what is the heap? All right, let's do it. Let's do this thing. We'll do it here. Well, need to pick a location. Let's just do it here. Okay, so in memory, memory is split up into a lot of sections, right? The two notable sections, the two main sections, are called the stack and the heap. Whoops. Heap. What is the stack and what is the heap? The stack, right? Whenever you make the stack, whenever you run your application, the stack is 1 MB of memory. Okay. And I found that out. There's a little thing you can do to find this value out. And we might do it today. You know what? We will do it. We'll just go through it. We'll do a like cool exercise. Because I remember I did it with a bunch of my students. And it was really fun to kind of find out how big the stack is. And since we did that exercise together, we never forgot how big the stack is. Okay? But the stack has a size of 1 MB. The heap is your entire RAM. Which is if you're running a 64-bit application, I assume the operating system will give you as much memory as you want. So if you have 16 GB RAM, your heap is 16 GB. Apart from, you know, what the operating system needs and what the other application needs. Let's say the operating system needs 60 GB plus all the other applications. So you're left with 10 GB. So your heap is 10 GB. And the stack is 1 MB. Now, whenever you're creating variables, normal variables, regular, good old fashioned values, variables, right? Good old fashioned variables. Whenever you're making variables like an integer or a float or a string, well, forget about the string. Let's not talk about the string. A double, right? Just your basic data types, Boolean, all of these guys. Whenever you create these variables, they are stored on the heap and they are deleted from the heap on their own. Remember when we talked about scopes? we said that everything in programming has a scope. So for example, this for loop, it has a scope. The scope is at line 30 and it ends at 33. This if statement has a scope. It starts at 20 and it ends at 66. So everything in the scope belongs to this if statement. Everything in the load function belongs to the load because there's a scope. This is its entire scope. The load function has all the scope because we have an opening curly brace and a closing curly brace. Meaning, if I create a variable over here and I say int health, right, this variable was created, it was allocated, it was generated, it became alive at line 19 in this function, and it belongs, this variable belongs to the function load, and it lives in load because it is in the load scope. Now this variable is destroyed at the end of the scope. Where is the end of the scope for load? Well, follow the dotted line, line 73. At line 73, when we hit line 73, this variable will be destroyed. It will be removed from the stack. When I first created it here, it was pushed to the stack. So what happened here is that int health was pushed to the stack over here. Right? Cool. And at the end of the scope, when the scope was over, we removed this variable automatically we freed the memory. We removed the variable from the stack. We removed that variable and we freed up the memory. And so any normal variable like this, it will be created where you create it, and it will be destroyed when the scope ends. And so I can make a custom scope. I can say, hey, health can live in the scope. This is just a random scope that I made. It starts at 21 and it dies at 23. Right? This is the scope. So this health variable, if I try to use it, if I say std cout health, right? It will not be able to find health because health only belongs in this scope. And it only exists in the scope. It was created at line 22 and destroyed at line 23. Right? If I put this inside, whoa, what did I do? If I put this inside the scope, now both of these guys, both of these lines of code belong in the scope. Okay? Cool. So I can create my own scopes. So this is pushed to the stack at line 22 and destroyed at line 24. And this automatically happens for you. C++ does that for you automatically. When you create a normal variable, it will be allocated, it will give it a little bit of memory, and then it will free that memory on its own when the scope is over. That's the stack. There's 1 MB of it, meaning you can have as many variables as you want, as long as it fits into this 1 MB. If you go outside this 1 MB, if the stack is full, you can no longer create variables anymore. You can't just say, you cannot create variables like int HP or int damage or whatever, or even booleans and doubles and floats and things like that, right? So you can't create variables anymore if the stack is full. And if the stack is full, you are going to get an error that's called stack overflow. And you might have heard of this website. If you go in Google and search Stack Overflow, right? It's a programming website. It's a forum to ask questions and get help from people, right? So here's questions. People ask questions and you get answers and things like that, and it's called Stack Overflow. And you can find jobs here, people post jobs and things like that, right? So the name of this website came from this error when you fill the stack, when you overfill the stack, when the stack is completely filled and you try to add more things to the stack. So the stack is part of memory that is allocated when you first start the program, and whenever you create a new variable, right? Like an integer health, the variable will be pushed to the stack and it will be removed from the stack when the scope is over, when we end the scope, and the scope ends with the closing curly brace. All right, so this is the stack, right? Okay, let's talk about the heap. The heap, on the other hand, is part of memory that it's the wild west. When you create a variable on the heap, right, even an array. So here, by the way, you can make an array. So int, okay, regular array. Let's call it n, and let's say there are 10 elements. This is on the stack. Okay, the heap is the wild west. If you need to allocate memory on the heap, you have to use the word new. And notice we did do that. Look at our program. We use the word new over here. For the love of God, where are you? Here, I said tiles equal new tile array. So when I use the word new, I went to the heap and I've allocated memory on the heap, right? Manually, using the new keyword. So whenever you use the new keyword, you're allocating memory on the heap. Okay. But that memory is not destroyed on its own. That memory, can you go away? Thank you. That memory is not destroyed when the scope is over. If the scope is over, if the map class is destroyed, this memory will still exist because I've used the word new. And so to remove this from memory, I have to use the opposite word, which is delete. So whenever I use new, I use delete, right? So now this array over here is not allocated on the stack. It is now allocated on the heap and exists on the heap. So now the question is, why did I create it on the heap? Why didn't I just keep it on the stack? And when should I use new? When should I use it on the stack? When should I use it on the heap? What is this? You're making things a lot more complicated than they should. Well, the gist of it is, I'll give you an example. Let's say one day you've decided to create an array of integers. And I guess this is the perfect time to talk about data types, right? And how big those data types are. So I'm just going to go brief, very brief. I'll go in more detail like later on in this session. But an integer is 4 bytes in size. Float is 4 bytes. Double is 8 bytes. Bool is 1 byte. Okay. Anything else? There you go. That's your basic data types. Right? So how many? So if an integer is 4 bytes and you have 1 MB of memory, that means you can fit a shit ton of integers over there, right? However, one day, let's say one day, you're like, I'm bored. You know what I'm gonna do? I am going to create an array, an integer array, call it numbers. This array will have the size of 987654321. This is how big my array is. So this is 100, 100,000, 1 million, 87 million, 987,654,321. Right? This is my array. This is how many elements I have in my array. So now if I run my application, I'm just chilling. I would like all the memory, all the data. Okay, well, go away. right? I would like all the data. Oh no, don't do that. Visual Studio, why you gotta be such a dick? Hold on. Can I just do a release? Will it work? No, fuck you, Visual Studio. Fuck you. Alright, let me remove just a bunch of these. Initialized health. Okay? And so, after doing that, after creating this massive array, what do I get? A Stack Overflow error. I got a Stack Overflow. Why did I get a Stack Overflow? Well, let's do some math. I have currently 1, 2, 3, 1, 2, 3, 9 million. I have 9,876,451 elements. That's how many elements I have. I need to figure out how big is that in MB, in megabytes, right? Because I know that the stack can only hold 1 MB. Okay, or I've told you, we have no way of verifying this. Maybe I'm lying. I could be lying. I lie a lot. I like lying. Lying is fun. You get caught, you go to prison because you lied. Liar, liar, pants on fire, and things like that. The fuck is wrong with me? You have no way of verifying that this stack is 1 MB, right? Okay. So here's the thing. What I can do, I know that an integer is 4 bytes, right? That's how much I know. And I know that there's 9,876,554 integers in this array. So I can just do the simple math of saying 876,554 and 554 multiplied by 4, because I have 4 bytes, because this is an integer and each integer is 4 bytes. All right, I get 506,164 bytes. This is in bytes. How can I figure out how much is this in megabytes? Well, you divide this number by 1024. So these are bytes, right? 39 million is in bytes. I divide by 1024 to get kilobytes. And so now I have 38,580 kilobytes. To get an MB, to get this number in MB, I divide again by 1024. And now I have 37 MB. This array is the size of 37 megabytes. And again, first you have bytes. Okay? Once you reach 1024 bytes, that is 1 KB, 1 kilobyte. Once you reach kilo or KB, right? Once you reach K bytes, 1024 kilobytes is 1 MB. Megabytes, 1024 megabytes is 1 GB. Gbytes, 1024 gigabytes is 1 terabytes, and so on and so forth, right? So if I have 39 million bytes, to convert them to kilobytes, I divide by 1024 and I get kilobytes. To convert the kilobytes into megabytes, I divide by 1024. To convert the megabytes into gigabytes, I divide again by 1024, and so on and so forth. That's because there are 1024 bytes in a kilobyte. There are 1024 kilobytes in 1 megabyte. There is 1024 megabytes in a gigabyte, and so on and so forth. So I got my Stack Overflow, right? Okay. So can we have a number that is not going to overflow? Well, what if I turn this to a 1? So now it's 1 million. Let's say 1,200,000. Let's see. 1, 2, 7, 6, 5, 4, 1. Multiplied by 4. That gives me 5 million. 5 million divided by 1024 is 4,986 kilobytes. Divided by 4 is... What did I do? Damn it. Can I just double click on this? Can you just copy this number for me? Thank you. Can you paste it here? No. Oh, it's fun. It's fun. Oh, that's fun. 1027 654 1 divided by 1024. That's this number divided by 1024. What is... Hello? 102 127 6541 divided by 1024. Get this. Divide by 1024. I get this. All right, so it's 1.2 MB. So that still will Stack Overflow us. We'll still Stack Overflow with 1.2 MB. You can see Stack Overflow, right? Okay, let's try now. Let's try to get a lovely... Let's try to reduce this. Maybe 1, 1. Okay, let's see. 1176541 divide by 1024 divide by 1024. I get 1.1 MB. That would still crash. So let's do 10,700,000. Let's try this. So 107,654,1 divide by 1024 divide by 1024. That's 1 MB and a few kilobytes. That will still crash. Right? 1 MB and a few kilobytes, still Stack Overflow. Because remember, the limit is 1 MB. We went over the 1 MB by just a little bit. Alright, so what I can do is drop this 7 to a 3. Let's drop it to a 3. Let's see what happens. So 103 654 1 divide by 1024 divide by 1024. Okay, so this number will run because you can see we are below the 1 MB threshold. So if I run this, this should run. Oh, we still over Stack Overflowed. I lied to you. I'm such a liar. I told you. I told you I'm a liar. You didn't believe me. You didn't believe me. Alright, but that's still over the threshold apparently. Okay, what if we drop this to a 2? Okay, so 102 6541 divide by 1024 divide by 1024. Alright, will this still crash? It did crash. Because look, notice in kilobytes, when we check in kilobytes it is what is it in kilobytes? 102,654,1 divided by 1024. In kilobytes, it's still 1,002, right? So we're still a little bit over the threshold, I guess. But all right. So what if I do 1? Will 1 work? Okay, 1 still crashed. Okay, let's try. Instead of 1, let's try 0. Will this crash? Still crashed. Okay. Alright, still crashing. What if I put this to a 3? Still crashed. Okay. What if I put this to a 0? Will it crash? Okay, wow, it's still crashing. Okay. Okay. Alright. What if I just do 0, 0, 0? Will it start crash? Okay, still crash. Still, a million is too big apparently. Million elements. What if I do 900,000? So 1, 2, 3, 1, 2, 3, 900,000. Really? Still? The fuck? Okay. What if we do 800,000? Oh, remember, this is still crashing because there are other variables on the stack. This is not alone. Okay. Hold on. If I... Okay, so it's loading other stuff in memory, right? So that's why... This is why it's not enough. Like, there's already existing stuff in memory. So if I comment all my code, and I just put this, and I just comment everything out, like literally everything, right? And I just do this. This will run. I guarantee you this will run. Before it was crashing, now it'll run. Okay, never mind. I'm an idiot. All right, well, 7. But my theory still stands. Okay, we're loading still things in stack on the stack. I'm gonna kill you. Like, there's no way. How are we stack overflowing? It's 100,000 elements. Can we not do 100,000 elements? Okay, we can do 100,000 elements. 200,000 elements? We can do 200,000 elements. 300,000 elements? We can't do 300,000 elements. Okay. What about 29,000? We can't do 29,000. What about 25,000? We can do 25,000. What about 26,000? Okay, we can't do 26,000. Okay, so 59,000. Okay, we can't do 259,000. What about 255,000? We can do 255. 257. We can do 257. 258? Okay, we can't do 258. But we can do 257. Right? Okay, 257, 9. Okay, we can't do 57, 9. 257, 5. And 500. We can't do 500. What about 200? We can't do 200. What about 100? We can do 100. Okay. What about, we said 200 didn't work? Oh, 200 works. Okay. 200. 300? 300 doesn't work. 200 works. What about 250? 250 doesn't work. 220? 220 works. 230? 230 works. 240? 240 doesn't work. Okay. So, 230. 235. Doesn't work. 231. Okay. 232. Okay. 233. Okay. 233 is the limit. So this is not a Stack Overflow. So 257, 232 is the limit of how much we can... How? That worked a second ago. You are... What the fuck? Sometimes it works, sometimes it doesn't work. Excuse me? That's no. No, you can't do that. You can't sometimes decide that you have enough memory and then all of a sudden decide, no, you're not gonna have enough memory for me. What the fuck? You either have memory or you don't have memory. What do you pick something? Okay, what if we do 30? Will 30 sometimes work and doesn't work? Okay, it worked this time. And it Stack Overflowed. Are you fucking kidding me? Are you actually serious? There's nothing that... What do you mean? How is this a thing? I'm confused. What about 20? Will 20 sometimes work and not work? Okay, it worked. It worked. And then Stack Overflow. Are you fucking kidding me? How can you Stack Overflow? Okay, maybe because it's debug. Can we switch to release? Okay, no issues. 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 No, okay. No issues. Alright, what if I go to 40? Will you have issues? You motherfucker, are you telling me that I have to redo this entire thing because I was in debug mode? Are you fucking kidding me? Alright, 6. Oh my god. You cannot be serious. 5. Okay, hold on. Let's figure out in debug. Let's figure out fucking debug. Debug sometimes. Okay, let's do debug. Let's figure out how big it's debug, and then we can go to release. Apparently, I didn't know there are two numbers, one debug and release, and they're both fucking picky as shit. Fucking asshole. Alright, works. 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 Okay. Apparently, this is how you do programming these days. Open that program like 700 fucking times, figure out which one works, which one doesn't work. Fucking bitch. Alright, 90. Works. 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 Okay. Motherfucking Stack Overflow. Okay, 50. Works. 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 Stack Overflow. How can you Stack Overflow? You fucking asshole. Works. I'm suspecting maybe I have to close the window before I run my application again. No, that didn't matter. Okay. I am going to sacrifice a goat because of you. Now, you might wonder and ask, why a goat? Why not a duck? Well, duck are fucking cute. Why would you sacrifice ducks? Why would you sacrifice ducks, you sadistic bastard? Ducks are nice. Ducks are cute. What did fucking ducks ever do to you? Ducks are good. I like ducks. Ducks help you program. Have you heard about the programming ducky? You should get the programming duck. Programming ducky. Look at this. How can you not love ducks? What kind of human are you if you don't like ducks? Look at this rubber ducky. It's so cute. It's so delicious. I mean, don't eat it, but it's so nice. Rubber ducky debugging. The rubber ducky debugging is a method as follows. Beg, borrow, steal, buy, fabricate, or otherwise obtain a rubber duck, bathtub, variety. Please, place the rubber duck on desk and inform it you are just going to go over some code with it, if that's all alright. Explain the duck what your code is supposed to do, and then go into detail and explain your code line by line. At some point, you will tell the duck what you are doing next, and realize that that is not in fact what you are actually doing. The duck will sit there. The duck will sit there, happy in the knowledge that it has helped you on your way. In a pinch, a coworker might be able to be suitable for a duck. However, it's often preferred mistake the duck instead your coworker. And if duck are so smart, So ducks. How can you not like ducks? What the fuck is wrong with you? You need a duck. Everyone needs a duck. I have a duck. Where's my duck? I don't know. It's somewhere. Ducky! Hold on, I have a banana. I have a banana, a fake banana, and a duck. The banana helps me on really hard problems. The duck comes on the easy problems. Hold on. Hear that? That's a genuine duck. Listen to that duck. Oh yes. Hey ducky. Shut the fuck up and sit down. Look, they're so fucking cute. Like, what do you not? I don't wanna deal with this anymore, okay? We're sacrificing a goat, not a duck. Period. Alright. Fuck you, Visual Studio. You and your shitty debug mode. Why do you have different values for the stack? Sometimes the stacks are big, sometimes the stack is small, sometimes the stack is enough, sometimes the stack is not enough. Why do you have different sizes for the stack for debug and release? Why do I have to do this to figure out the size of the stack every time I want to feel? I don't know. Funny. It works. 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 It. Oh, you bitch. Alright, I give up. I'm going to say that this is enough for debug. Let's figure out how big this is. 257 010 divide by 1024 divide by 1024. It's barely a quarter of an MB. You fucking. That's how big it is for debug. I don't understand. I don't get it. I genuinely get it. I don't know why. Let's do release. So for release, I know for the fact that this can go all the way to 8. As you see, I'm not fucking crazy. It works. 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 Alright, all this works. Let's do 9. It works. Let's do another 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 9. It works. Let's do 1 0 0 0 0 0 0 1. It works. 2. It works. 5. It works. 9. How the fuck is this working? 2. It works. 3. It works. 5. Okay, we passed the 1 MB. We passed the 1 MB fucking threshold. Guys, I don't know how big the stack is. 9. 1, 2, 3, 4, 5. Or not multiplied, divided by 9 9 0 0 0 0 0 1024 1024. Apparently, on release mode, you have 10 MB or even more, because guys, I fucking lied. I don't know what the fuck I'm saying. I don't know what I'm doing. What are you trying to do? I'm trying to figure out how big the fucking stack is. How big is the stack in 64-bit C++? I hate my life. I wanna die. Ooh. Can you just tell me how big it is? Can you just tell me how big it is? Can you? How big the fucking stack is? Why is the stack so big? I don't fucking know. If I knew that, you know? If I knew that, none of this would have been a problem. Alright, guys, I give up. I don't know how big the stack is. I thought the stack was 1 MB, but apparently it's not. And so I can add even one more 9 here. And in release mode, hold on, is this memory even allocated? I'm now suspicious. I'm now suspicious. I'm now suspicious that this memory is not even allocated. I'm very suspicious. Okay, I don't know. I give up. You know how I said the stack is 1 MB? Apparently I fucking lied. Because all this time I thought it was MB. And we did this in class, and we found out that's 1 MB. But I guess I was in debug mode. So I don't fucking know. That's yeah, I thought it was 1 MB too. But like apparently it's not 1 MB. In Visual Studio the depth stack is 1 MB. Okay. But how in release mode it's not 1 MB? I don't know. Anywho, doesn't matter. Bridge under the water. Water under the bridge, or whatever the fuck they say. Going back to this. Okay. If the stack is full, and let's go into debug mode and see a number that didn't work. So, for example, this number didn't work in debug mode, right? Where's the main class? Right, sorry. Right? So, if you fill up the stack, if you're like, hey, I filled up the stack, and you get a stack overflow error, that happens because you've allocated way too much memory on the stack, and the stack has a limited amount of memory. What is this limited amount of memory? I don't fucking know. I thought it was 1 MB, but it turns out it's not. So, here we go. So, going back to this, right? Now your stack is full, and because your stack is full, you cannot allocate any more memories. You cannot add any more data, or you cannot add any more variables. The stack is full here. So what you can do instead is take that array, move it from the stack, and put it in the heap using the new keyword. And in the heap, you have all of your RAM. You have access to all of your RAM. So if I press play, you'll see that this is crashing. I'm getting a stack overflow on this number, right? You can see stack overflow, right? So instead, what I can do, take this array, okay, copy this, make this a pointer. So this is a pointer now, right? And this pointer now is equal to new int, and this is an integer array on the heap. And so if I run this, I will not get a stack overflow anymore, because now all this data is allocated on the heap, It is not allocated on the stack, right? So whenever you're using the new keyword, you're allocating memory on the heap, not on the stack. The stack has a limit size, right? And you can't put a lot of data inside the stack. In the heap, you have your entire RAM, but you have to use the new keyword. Whenever you use the new keyword, you have to use the delete keyword to delete that memory, right? And you're responsible, in C++, you're responsible for managing your own memory, right? In C Sharp, in languages like C Sharp, you have something called the garbage collector. And the garbage collector is a program that runs underneath your program that basically deallocates memory for you, or it deletes memory for you. So in C Sharp, you use the new keyword all the time, but you never use the delete keyword. There's no delete keyword in C Sharp. Okay, I lied. There is the delete keyword, but you don't use it in C Sharp. The garbage collector will go and free memory for you. It will figure out when you have freed that memory or when you don't need that memory anymore, and it will delete it for you. In C++, you are responsible for managing your own memory. Whenever you use new, you have to use delete. And so that's why what we did here is we created a pointer, right? And we talked about pointers. And that pointer points to our array, which has this size. And I can make my array like huge. I think it's now like 9 GB. I don't know. How big is this array? Let's go to that. Or look, 4 GB. Look at that. My game is now 4 GB. You can see here the process 4 GB. And if I go to my task manager, it's gonna say the same thing. I'm randomly checking how big the stack is because I was talking about the stack, and I kind of wanted to prove to everyone that the stack is big. And so that's why I kind of did that. So task manager, where's my game? Here, 3.8 GB of memory, right? And the reason it's taking this much is because of this massive array. If I reduce this array, right, now it's gonna drop from 4.5 GB to a smaller value here on the right. You'll see now it's 700 MB, right? That's because I'm allocating this much. If I remove this entire array, now it's gonna drop to like 50 MB, 300 MB. Yeah, so it went to 4 GB, from 4 GB to 300 MB, and from 300 MB to 700 MB to 300 MB. And I think it's 300 MB is because I'm allocating memory here. Yeah, I'm allocating memory here, 288 elements, right? So that is the stack. That is the heap. You should use the stack when you're trying to allocate a lot of data. Sorry, that was wrong information. You should use the heap when you want to allocate a lot of data, large amount of data. And you do it using the new keyword. However, you have to use delete later on because that memory will not be freed. You have to free it. And if you don't free memory, that's called a memory leak. You're leaking memory. A memory leak is very bad. You shouldn't have a memory leak in your application because that means you're allocating memory and you're never deleting it. And so whenever you use new, you have to use delete, right? That's for the heap. For the stack, you can just allocate memory normally, like a boolean or an int or any of these objects. Do you see these objects when I'm creating? Let's go here. When I'm creating an object like frame rate or map or player or skeleton, all of these guys are on the stack. Every single one of these are on the stack. The only time you will see things are on the heap when you see the word new. When you see the word new, that is on the heap, right? And so, and in this case, the reason I put my tile array on the heap is because if I put it on the stack, I had to initialize it over here. I would have to set the tile array in here, but I don't know how big this array should be. I have zero idea how big this array should be. Am I dropping frames? Am I dropping frames? Okay. Um, YouTube's telling me that. Okay. YouTube just is like, hey, um, your thing is not going well. So I don't think I'm dropping frames. So I think, yeah, I think everything's fine. By the way, are you going to talk about smart pointers? At some point, yes. I think there was a way you forget about delete, and it would delete when the scope ends, right? Yeah, that's what smart pointers. We'll talk about that later on. But anyways, for this part, yeah. So I literally so essentially what I'm doing, rather than putting this on the heap and setting the array, that how big the array is, the size of the array, I can just make a pointer that points to the array later on, and I can allocate how big the array is later on when I figure out how big I want my array, and this array would be on the heap, which is good, right? Okay, so that's the stack, that's the heap. Now one more thing on the stack I want to cover on the stack is that not only variables live on the stack, function calls live on the stack, right? So let me give you an example. How would the application know where you came from? So for example, if I have a function called hello or reduce player HP, and it, I don't know, std cout xd. If I did this, right? How would I, how would the computer, right? How the computer, how would the computer know that when we reach this line, we should jump in here? And when we jump in here, how would it remember where we were before? Because when we finish executing this function, we need to go back to the main function. How does the computer know that when we're done executing this, we should go back to main? Well, it knows this because it keeps track of all these in the stack. So it keeps a pointer in the stack of where we were. So for example, if we are in the main function, it says, hey, you're in the main function. If we go to reduce HP, it's going to say reduce HP. This is the function here. And when we're done with reduce HP, it's going to remove reduce HP from the stack. And now we go back to the main function, right? So in the stack, we keep pushing things. We push things on the stack and we pop them out. And when we pop things out, we go back to where we were before. And so if I want to go to a function, I don't know, like reduce HP, I just add it to the stack, and when I'm done with it, I pop it out. And then when I pop it out, I know where I was before, which is main, right? So the stack is not only used for variables, it's also used for functions and figure out where we were before. And the stack is really helpful for debugging too. So we'll go over that later on. All right, I need to drink a little bit of water. I've been talking for like 3 hours straight, nonstop. Give me a second. All right, so that's the stack, and that's the heap. We covered those up finally, which is good. Um, but yeah, goodbye, goodbye. All right. So going back to what we were trying to do, which is the map over here. I load my map. I set how big the map is, right? So to do that, I need to create a variable called int total tiles, and total tiles is going to be equal to total tiles on X, total tiles on Y, and this I'm gonna allocate how many tiles I want, right? So there we go. And now I can just do total size over here. All right. Okay, so this is all good, right? I load my tile sheet. I calculate how many tiles in my tile sheet, and I store it in this variable. And then I generate an array of tiles with the amount of tiles I have in the entire tile sheet. And I loop through this array, right? And I set the ID for every tile, and I set the texture for every single tile, right? Now, after I do that, essentially now, what I've done is I've went through this image, and I've categorized this image, and I've said, hey, listen, you have an ID of 0, you have an ID of 1, an ID of 2, 3, 4, and so on and so forth. This is an ID of 24, 25, 26. So I went through every single tile, and I gave every single tile an ID, and I told each single tile, I told it that, hey, this texture is your texture. I've done that. That's done, right? And it's done using this array over here. All right, so that's good. Let me put this set here at the top. So that's good. What's next? Well, next, what I need to do, what do I do next? Next, I need to set the sprite, right? Next, I need to do the sprite stuff. So I'm gonna say tiles dot sprite. I'm gonna set the texture for the sprite. I'm going to set the rectangle, right, for the sprite, right? Sprite.set texture rectangle. We covered this before, but the problem right now is only we're doing it on X, we're not doing it on Y. So we need to fix that in a second. I'll show you a solution to do that. I need to set the scale for everything to scale it all up, right? And then finally set the position for everything. So set everything up, right? So we have to do all that. All right, so we've done all that, right? I'm looping through every tile, setting the ID, setting the texture, and then setting up the sprites. Okay, but I'm only doing it for x-axis. I'm never doing it for the y-axis. How can I do it for the y-axis? Well, to do that, rather than just having a single loop, what we can do is have two loops. One loop for the y-axis, and one loop for the x-axis. And so this will change a little bit, right? So I'm just going to write up the code for now, and then I'll explain and go through it in more detail. So this will be total tiles on Y. This will be total tiles on X, right? And instead of I, we don't have any I anymore, so we need to make I. I is equal to X plus Y multiplied by total tiles on X. I'll explain what this means in a second. And so now I'm doing I for all of these, which is good. Next, what I need to do, instead of I here, I do X, and instead of 0, I do Y. And instead of I do X, and I basically copy this same line. Instead of X, I do Y. I'll just do an offset of 0 and 0. So they both, or an offset of maybe on X 0, but on Y, let's drop down by 50 pixels. All right. And when I render everything, I just need a single loop. And again, I'll go through all of this and I'll explain it in a second. And so now I do tiles at I dot sprite, and I draw all the sprites. So if I press play, I should see my entire texture. Right, like so. I see my entire texture. But the very important difference now is that every single one of these guys are a tile of its own. So I can only draw this tile, for example, or I can only draw this tile. Each one of these are stored in their own class. All right, where before we were just rendering the entire texture. I'm not rendering the entire texture, like not one image. I'm rendering everything. I'm splitting up everything to smaller images and rendering all of the images. All right, so let me explain this. So to do this, what I'm going to, where's my pen? I lost my pen. Oh, here it is. Okay, let me explain this. The problem that we had before is that everything was in a single loop, right? Everything was, I was just doing for int I equal to 0. And the problem with that is when I wanted to go into the set texture rect, right? And I wanted to get the X and Y axis for the position of every single texture. I wasn't able to do that. And the reason I wasn't able to do that is because I had no way of knowing which tile I am at or which tile I want to go to. So before, if I look at my code, put this side by side, right? This like this a little bit. Okay. Before, so we all agree, or we all know that this part over here, this over here, and this over here, this is the position of every tile for X and Y axis, for the X and Y axis. And before, this was I multiplied by tile width, and this was 0 multiplied by Y, meaning what would happen is I would get this tile, this, every tile in a single row, on one single row. But then I wouldn't be able to go to the second row because Y would be 0. There was no Y. Y was 0, right? It was I and 0. That's it. So rather than just having a single I that goes through, basically say I is less than total tiles, which is 288 tiles, right? Rather than saying I is less than 288, I needed a way to figure out how many tiles are on the x-axis, and then when I'm done with the x-axis to move to the y-axis, right? And so to do that, I have two for loops. The first for loop, and I put the while loop at the very start, right? So let's go through this together. Y is equal to 0, and then I go to the inner loop. The inner loop says x equal to 0. Okay, x is equal to 0. Okay, and in here now I don't have I anymore, right? Or I have y and x. I have an x and y, where before I had a for loop with I in it, but I don't have I anymore. So essentially what I've done is I now have two numbers. I have x and y, and I would like to convert both of these numbers into a single number, one-digit number, one-dimensional number that tracks the index in my array, right? Because my array, so I have an array that is 288 elements. And if I have I only, that means I just go 0, 1, 2, 3, 4, 5, 6 until 288 elements, right? So I go all the way to 88. But that's a problem, because with set texture rect, I need to figure out the x and y. I need to figure out the position of every single tile where that position is. So I wouldn't work. A single for loop wouldn't work. So what I've done is I've split it into four loops, the y and the x. And then now that I split into four loops, I have a problem. I need to figure out how to index my tiles. Like, how can I go from 0 to 1 to 2 to 3 for every single tile for x and y, for both x and y, right? Now what I want to do is I want to forget that I have this. I want to assume that I only have I want to assume that I only have a 3 by 2 a 3 by or 4 by 2 grid, just to explain this, because explaining this on this big massive space is a little bit hard. So I have 4 elements on X, and then I have 2 columns or 2 rows. I have this row and I have this row, and in every row I have 4. So this is index 0, this is index 1, 2, 3, 4, 5, 6, and 7. These are all my indices, right? And so, but I don't have I only have X and Y, and Y is at 0 currently, and X is at 0. So the question is, how can I take Y and X and convert it to I, so I can iterate through my tiles, my single array, my one-dimensional array. So I have one-dimensional array, one array. How can I take 2 numbers and and loop through that one array? Well, what I can do is I can use this line of code here. So let's see what this line of code does. It's the formula. This formula is always used. It says take the X component, which is 0. So 0 plus take the Y component, which is 0. Multiply Y by the total amount of tiles I have on the width. So how many tiles do I have? I have 1, 2, 3, 4. I have 4 tiles on the width. So multiply by 4. So let's see what that gives us. If X is 0, Y is 0, and how many items we have on the width is 4, 4 by 0 is 0, plus 0 is 0. So I is 0 if X and Y is 0. So I do I, tiles at 0, I set the ID, I set my texture, my texture rectangle, scale, and position. So that's if X is at 0. Now, when we're done, when we reach this point, we increment X by 1, right? X plus plus. So now X is 1. X over here, let me just put this here. So X is now 1. We've incremented X by 1, right? Because we finished our first X loop iteration, now we're going to the second one. So X is 1, right? So let's plug in this in the formula. What happens when X is at 1, right? 0 multiplied by 4 is 0, plus 1, this is 1. So now we went to the second element, right? In memory, we were at 0, and then now we're at 1. So now we are at 1, right? Okay. So now we did 0. Let's do 0 here. And now we're at 1. Okay. So I do everything. I do tiles at ID equal I, and blah blah blah. And then I incremented by 1 again. Now X is incremented by 1. Now X is 2. Okay? So let's plug in 2 over here. 2 plus so 2 is here. 0 by 4. 0 by 4 is 0. Plus 2 is 2. Right? So now we're at 2. Right? In memory, we are at 2. So we do all of our things. We did tiles I and so on and so forth. X is incremented by 1. So now X is 3. Right? So let's plug in 3 here and see what happens. 0 by 4 is 0. Plus 3, we're at 3. So now this is 3. I is 3. We do all of our things here. We're done. And we were here. Okay. We're done with X. X is less than the total size of, or total tiles of X. We're done with X. We finished this loop. Now we exit to Y. Okay? Y becomes 1, and X goes back to 0. Because when we finish the inner loop, when I finish the inner loop over here, I jump to the outer loop. I execute the outer loop. And the outer loop executes Y plus plus. When Y is plus plus, X, we go inside X, and X is reset to 0. Okay? So now Y is 1, and this goes to 0. Alright? So let's see. 1 by 4 is 4, plus 0, it's 4. So now, I am going over here. right? I execute this in memory. I execute this element in memory, right? And then x is incremented by 1. So let's increment x by 1. So x is 1, right? 1 by 4 is 4 plus 1 is 5. So now this becomes 5. Now we are here in memory, 5, right? We increment x by 1. So now it's x is 2. 2 goes here. 1 plus 4 is 4. Plus 2 is 6. Now we do 6. Now we're here at 6. Finally, x is at 3 because we did 0, we did 1, we did 2, 3 is the last element. X is at 3. We put 3 over here in the formula. 1 by 4 is 4 plus 3 is 7. So now we go to the 7th element. When x is done, x reached 3, x is maximum. It goes to y. Y has reached the maximum because there's only 2 rows. This is at row 0. This is row 1, right? And this is 1, 2, 0, 1, 2, and 3. So x can only go up to 3. Y can only go up to 1. We're done, right? And that's it. That's what this formula does. It basically takes my x and y and it converts it from 2-dimensional number to a single-dimensional number, which I can use to index my array, to go through my array, right? And the reason I did 2 loops rather than a single loop is because of these lines. Because I need to go through my list of elements. I need to go here on x, then move to this x, then this x, 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 right? Do all of my x. When I reach my x, I increment y. So now I move y here. And I do x, 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 x. And then when I'm done, I go to y again. And then x, 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 x. When I'm done, I do y. And then x, x, x. And then I do y. And so on and so forth, right? So that's why I needed 2 for loops to do my x and y for my rectangle, my texture rectangle. All right? And it's also useful for my texture here. So everything, all of these guys, they have different positions, right? So every tile now has a position. So think about it again. For x multiplied by tile width, what does that mean? Well, if x is 2 and my tile width is 16, 2 by 16 is 32. So as long as x is incrementing, I keep moving my tile one position over. So rather than all the tiles are stacked on top of each other and drawn on top of each other, they are drawn now next to each other because x moves forward, y moves forward, right, in my loop iteration, right? So that's what that does, right? And for the ID here, I'm just setting the ID equal to I, right? Because I goes from 0 to 288. 288 because we have 288 tiles. Like in total, all of these tiles, there are 288 of them, right? And so I have 288 tiles here. So for every single ID, for every single tile, I have a unique ID, right? So I'm setting the ID, I'm setting the texture, I'm setting the texture for the sprite. For the texture rectangle, I'm setting the position. Where should this tile have the position? Which tile should I render? So I set the position, for example, here for x, and then I set it for y, right? And then I draw a border, and I say, hey, this tile at index, I don't know, 2 has this coordinate, has a position, and it has this position, and it has this width and height. And I move on to the next tile. I say, hey, the next tile position is over here, and this is my ID for it. And I move to the next tile. I was like, hey, and I have this coordinates for here, right? So I do it for every single one. All right, hope that made sense. If it didn't make sense, go through it. Think, like I mentioned, literally think like a computer. Go through this and think, what's the computer doing? We set y, we create a variable called y. Y is less than the total tiles. and then we move to X, and then we execute this formula, and so on and so forth, right? Which is cool. All right, so this is my entire tiles. All my tiles are here, right? And so this is the cool part. If I decide that I want to the position of all my tiles, if I decide that all of them are 0, 0, then now all of them are at 0, 0. So now all of them are stacked on top of each other. All of the tiles are stacked on top of each other. Every single tile is individual, which is kind of cool. Okay. So now that I have all my tiles over here, they're all rendered. Now what I can do, this is the really cool part. Rather than rendering all of the tiles all together, what I can do is do the following. Let's say I do this. What I am going to do is create another tile array. Okay, I'm gonna say, hey, I would like an int tile IDs of size 5. Or not 5. I want 3 at the top, and let's say 6. Okay, I have tiles IDs at 6. And so what I want to do, okay, what I'm going to do here is say that inside this array, I'm going to have the following numbers. And you can initialize an array like this, which is kind of cool. So this will have an ID of 0. This has an ID of 1, right? So I'm going to say, I want to draw 1, 1, 1. And on the second one, I want to say, I would like to draw, so at the very end, I know that this is the 24th tile because I counted 0 to until 24. So this would be 25. So I'm going to say this is 25. Okay. And then I'm going to say that, so this is 25. This is 20, 25, 26, 27. Let's do 27 next. And then I'm going to say 27, 25, 26, 27, 28, 29, 29, 30, and 30. Okay, so I have an array. Oh. So I have an array of numbers, right? So I'm saying, essentially what I'm saying, I would like to draw tile number 1, and then draw tile number 1 again, and then tile number 1 again, and then draw tile 25 under it, and then tile 27 under it, and next to it, and then tile 30 next to it, right? Just have a bunch of IDs, and they just look like this, right? But they look a little bit confusing like this. So what I've done is I put them in on kind of rows like that. So now what I can do inside my load function, this is really cool. Inside my load function, I can do this. I can have a for loop, right? And again, it will be a for loop for x and y. So this is going to be x. Sorry, this is y is above x, not. So y is here. Okay. I have a for loop here. Okay. What I am going to do here is do the following. Do I need sprite? No. I'm gonna remove sprite, guys. So I put the sprite in the tile, but I'm gonna remove it. I don't need it. So I'm gonna remove sprite. And instead what I'm gonna do, so I have an array of IDs, and then I'm going to have another array of sprites. So SF sprite and call it sprites, or I'm gonna call this the map. This is my map, and this is map numbers, and this is my map map sprites. And this is also going to have 6 elements, just like the numbers, right? I don't need any of this anymore. Actually, I do need this. I do need this. Let me think. Do I need this? Ooh. Okay, hold on. This is interesting. I'm stuck. Okay, so this is 3. So this is 2. This is 3. Because if I look here, there are 3 elements on X and 3 elements on X, but there are 2 only on Y, right? There's only 2 rows, but there are 3 in each row. There are 3 elements, right? So on Y, I'm doing 2, and here I'm doing X. Okay. All right, and in here, what I'm gonna do, I'm gonna say maps at. Gonna use the same formula, and it's always the same formula. Go to tiles now. It's gonna be 3, because I know there are only 3 numbers here. There's only 3 tiles next to each other. 1, 2, and 3. All right, so only 3 tiles. I'm gonna put I over here. So this is map sprites at I. Okay. I need to set its texture. That's the first thing I need to do. Set their texture. The texture would be tiles. Okay, this is interesting. This is interesting. We need 3. We're gonna have to use 3 loops, not 2 loops. Okay, this is not the most optimal performant code. We're gonna optimize it later on. Okay, this is what I have in my head. This is what I want to do. Okay, this is what I have so far. I have a table. Right, I have a table over here. Right, an array essentially. I have an array with all of my tiles that ever exist. All of my tiles, every single tile has an ID 0, 1, 2, 3, 4, 5, 6, 7, and so on and so forth, right? And it's this. This is that array. Every single tile exists in here, and they all have an ID. And the code that does that is this code, right? It loops through my texture. It goes through my texture and sets the ID for every single tile, and it sets the texture for every single tile, right? The other thing that I need is this. I do need this. But we can just do an SF rectangle. So just let me do this real quick. SF rectangle. Int rectangle, and this would be, I don't know, rect, right? And tiles rect is equal to in here. So, and for every single tile, I know the rectangle of it. I know its starting position, its starting position X and Y, and the width and height of it, right? So all this data is kind of important. Okay, so I have that table. I have this table. I've set up this table. What I want to do next, okay, I need to create another table. This is the table for all the tiles that exist for my map, right? This is that table. All the tiles that exist for my map exist over here, right? And this goes to 8, 9, 10, and so on and so forth. What I have next is my actual map. I just want to do this. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 1. 34, 35, 36, 87, 38. Almost done. Okay, I've numbered all of them, right? So this is a table that contains all of my tiles, which are these, and each one of these tiles are numbered and they have an ID. Okay, this is the table. I need this table. Next, I have my actual map. This is the map that I have designed. I have worked really hard to design this map, and this map looks like this. Now, what I'm saying here, right? I'm saying I would like the first tile to have an index of 1, and 1, and then 1. And then here 27, I believe. What I do in the code? I said here 25, 27, and 30. So this is 25, 27, and 30. Is that correct? Yes. So this is my map. This is my actual map. This is what I want to draw on the screen. So what should happen, essentially? The code, or I'm going to loop through this map. I'm going to go here, right? I see number 1. So what I'm going to do, I'm going to look up in this table. I'm going to go to this table, and this table just contains all of my tiles, my lovely drawings. I'm going to find ID of 1. I'm going to figure out that the ID of 1 has the coordinates over here in my actual tile sheet, right? I know that this is tile 1, and I know this tile 1 has this information. I know that the position of this, if this is 0, 0, this will be 16, 0. So this is the position of my tile, and this is the size of my tile. I need this information. This information is vital to figure out where the tile exists on this texture. So you can think of this as a lookup table. I am going, if I find ID number 1, I need to go to this table over here, this table, okay? And I need to figure out which one is ID 1. I know that this is ID 1. I go in here and I look at these coordinates. This is the position, this is the width and height. Once I find these coordinates, what I'm going to do on my screen is draw this tile. Draw it over here. And so next to it, I'm going to draw another tile of index 1, and then I'm going to draw a tile of index 1. So I'm going to draw this tile 3 times over here, right? Next. Now, tile 25, and I know tile 25 is this. So now I go here, I go to this table, look at this index. I find the ID 25. In 25, I look at its position. What is the position of 25? Well, I can figure that out, but I'll have it all stored, obviously. But the position of 25, I know that the width and height and the position, I know the width and height of every single one of these is 16 by 16. Like all of these are 16 by 16. I know that for a fact. But I need to know the position. The position is at 0, 16. So on the Y, this is 0. We go on the Y, 16 pixels down, and this is where the cell is, right? And I'm doing this for every single one of these, right? That's my objective. That's what I want to do, right? And so this is my map. This is what I want to draw on the screen. This is the actual just table that exists. This is my lookup table. Okay. And so my lookup table in the code is this tiles over here. This is the lookup table. And this is the actual map that I would like to draw on the screen. So what I need to do is I need to loop through my map over here. And I need to find the corresponding ID. So I know that this ID is 1. So I need to go inside tile and find ID number 1. This is easy. I don't know why I'm overthinking this. So I just do here, I just do tiles at index, at the index of Okay, I need to do this. Hold on. Int index equal. This is gonna be map numbers, or map numbers at I. I need to do tile at index, right? Dot texture. I need to get its texture. Okay, so I'm setting the texture. I need to dereference this, right? Remember, because look at this. Set texture require the memory address of texture, but my texture is a pointer, so I need to dereference it. I'm dereferencing the pointer. So I'll explain this code in a second. But so that's my map. I'm getting the texture. I need to set the texture rect. Set texture rect, which is SF texture rect. I can get it also from the styles dot rect, right? I can set the texture rect over here. I need to set the position. So set position. Ooh, I'm using set position over here. Ignore that. Ignore that ooh. Set position. This is SF vector to F. And this is going to be X multiplied by 16. Y multiplied by 16. I'll explain this in a second again. Don't worry, I'll explain all that. I need to set the scale, because I need them to be a bit big. So set scale SF vector to F. That is 5, 5. I need to multiply by 5 here, because I'm setting the scale by 5. I'm moving the scale by 5. Okay. And that's it. So I do this. I think that's it. And now I just need to draw. What I'm gonna draw is my map sprites. So for 6 elements, window.draw my map sprites at I. So in theory, what should happen now is what I'm gonna see on the screen is the tile at index 1, tile at index 1, tile at index 1, tile at index 25, 27, and 30, right? Because each one of these tiles has an index, and so I'm gonna draw this tile 3 times next to each other, and then go down, draw this tile over here, and then draw this tile over here, and then draw this tile over here. Okay? That's what I'm supposed to happen. Let's see if that worked. There you go. Hold on. Did I misjudge this? I think 29, not 30. Let's do 29. Did I count wrong? This is 24, 25, 26, 27, 28, 29, 30. That is 30. Okay, let me see what 29 gives me. Did I mess something up? It gives me this. But how is this 29? Am I misremembering this? So this is 29. How many elements are there? 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Wait, did I start from 0 or did I start from 1? Fuck. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 30. Wait, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, 23, 24, 25, 26, 27, 28, 29. Yep, I was calculating from 1, not from 0. So all these are minus by 1. This is 26, and this is 24. All right, so there you go. I'm rendering the correct tiles that I want. What if I want to render this tile over here? Okay. What if I want to render 3 of these tiles? Well, if this is 23 plus 23 plus 23 3 times, what does that give me? 23 plus 23 plus 23, 69. So this would be 69, 69, and 69. Okay, well, 69 didn't work. Why? What am I drawing here? What is this? I need to offset all this by 100 pixels on the y-axis because I can't see shit. So I'm just gonna do 100 pixels plus on y. So just drop everything by 100 pixels. Okay, so what am I drawing? What is this? Which one? Which part of this? Which part is this? What did I mess up? It would be the one that has transparency in it. That's weird. Okay, this is row number 1. This is row number 2. Oh, there's only 2 rows, not 3 rows. Wait, no. This is first row. This is the second row. This is the third row. I think 70, not 69. Try 70. Try 70 and see what happens. $70 gives me this. What is this? Which tile is this? It's either 70 is giving me this. How is this happening? Oh, or is it this one? Something wrong here. Something very wrong. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, let's try 11. Let's try 11. 11. See what 11 gives us. 11 should give me that. So 11 should be right. I should get this, or half of it. Yeah, I get 11 correctly. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So this is 23. All right. And then I have the line over here. This is the line. This is 24. Okay. 23 plus 23. I should get 46, which would be this empty one. 46. And then I have this row. This is 46. Row number 1, row number 2, row number 3. Oh, this is row number... No, this makes no sense. This cannot be 16 pixels. Can I just draw a line? Oh, I need the pro version. Nice. This is 16. There was the cutoff for this one. Cutoff should be here. 0, 24, 24, plus 24, 0, 24. This is plus 24. Plus 24 should get this. 72. Oh, I did get 72. Alright, there you go. I did the math wrong. 72. Cool. So this is 72. If I want this door, let's say I would like to draw this door over here. Right? So if this is 72, then I should add another 24. Okay. Let me add another 24 here. 24 plus 24. 72. So 96. So 96. So do 96 and 96 and 97. So I would draw the door. Nope. Nope. It gave me, what did it give me? Shell is this? Has to be a better system than this. 96 gave me this, which is over here. How did 96 give me this? Okay, brought 120. Okay, there you go. That's 120. So 120, 121, 122. There you go. We drew the first part of the door. Right, this top part. And then if I want to draw the bottom part, I just need to add 24 to that. So 120 plus 24, 144. It's 144, 145, 146. So there you go. I drew that part of the thing, right? And so this is it. This is literally what I do. This is my map now. I specify which tile ID I want to render, right? Each one of these tiles has an ID. I specify which tile ID I want to render, and then I make an array of all my map sprites. In my map sprites, I'm looping through my map. I know there's only two of these on the Y. There's only 2 rows. On X, there are 3 only items. There's 1, 2, 3. I'm using the same formula that I showed you before. So X plus Y multiplied by 3. And the reason there are 3 because there's only 3 of these, right? This is the width. There's only 3 elements. So I'm converting 2 numbers into one number, one index number. And then what I'm doing now is using that index number, I am accessing. So if I is 0, I'm going through this array, this map array. So if I put side by side, this was side by side, right? Map numbers is this array. If I is 0, then the value of index is 120. So now what I'm doing, I'm using this number 120 to access this array of tiles, right? That I created at the top, this array of tiles that I created at the top, this table, this lookup table that I created, this lookup table over here, right? This lookup table, right? I'm looking for the index 120. So I access my tiles over here, and I find 120. 120 would be this, right? This here would be 120. This is the tile ID 120, right? So inside this tile array, At index 120, I'm setting the texture, dereference it, right? Because this requires a reference, and this is a pointer. And so pointer holds memory addresses. In order for me to get the value, I need to dereference the pointer to get the actual texture. So I get the texture, and then for the set texture rectangle, I use the same index to get my rectangle. I set the scale, and in here, all I'm doing is I'm saying, hey, the position of my tile is going to be at x, which is 0, multiplied by 16, because my tile is 16 width, multiplied by 5, because my scale is 5, right? And that's for the x. So the first texture is going to be, the first tile is going to be at 0, and then it's going to be moved at, x will be 1, so x was 0. When 0 by 16 by 5. 0 by 16 by 5 is 0, right? It is 0. Next, x is 1. 1 by 16 by 5, this is 80, right? And then x is 2. 2 by 16 by 5 is, what is it, 180 or something, 160? I don't know, something along these lines, right? And so the position of my tile is at 0, then it moves to 80, and then it moves to 160 or something like that, right? So it's moving along. And same thing for the y-axis. For the y-axis, I've said, hey, I would like an offset of 100. So I would like to start with an offset of 100 to give me 100 pixel space, because the reason I did that is because you can see it was colliding with the text. Like if I was rendering this at the top, it was colliding with the text, and it was hard to figure out what's going on. So I moved the map 100 pixels down, and I did the same formula. So when y is 0, 0 by 16 by 5, and I render that, right? And I set all this up in the load function, and I do all this once. So now I am basically, for every sprite here over here, for every sprite, I have 6 sprites. For every single sprite, I am setting its texture rectangle, its scale, and where the sprite should be rendered on the screen. And then I loop through all my sprites, and I render them, right? So this is the actual map. This code is for the actual map. This code is for the lookup table. I'm just creating a lookup table. That's all. I'm just going through this entire texture. I'm giving every single tile an ID, and I'm figuring out where every single tile, where their position is. Okay? That's all. That's all I'm doing. And it's a really, really cool system. Now, with that all said, there are a lot of optimizations that needs to be done right now, because there's a lot of redundant data. Some of the redundant data that I have currently is for every tile I'm storing, this rect is storing where the tile is on the X position in the lookup table, this table, where each tile, its X position, Y position, width and height. I don't need its width and height, because in my system, all the tiles have the same width and height, 16 by 16. So I'm wasting a lot of memory by storing 16 by 16 for width and height for every single tile. And I don't need to do that, right? So rather making a rect over here, right? Instead of a rect, I can just make this a vector instead of this, because this is 4 floats. Instead of making it 4 floats, I can just make it an SF vector 2f and call it position. So this is the position on vector 2i. I'll just do vector 2i. This is the position, or a float, just vector 2f. This is the position of my tile in the lookup table. Like this tile, for example, where it is positioned in this table, right? So that's that. So now I have to change the code a little bit in here. So in here, instead of doing this, I'll just do SF vector 2f. This is the X. This is the Y. Right? And this is called position. right? I don't need this data anymore because I know for a fact that every tile is 16 by 16 pixel. So now I need to construct the rectangle over here. So the rectangle will look like this: SF float rect. That would be dot position dot x. So this has to be in multiple lines to make it a little bit clear. So this is x, this is y, and I know the width of my tile. I have a variable for that, the tile width, 16, tile height, 16. So I'm constructing this rather than storing it and wasting memory. What's your problem? Oh, needs an interect. All right, if it needs an interect, then this just might as well be vector to I, not vector to f. There's no reason it would be. There's no reason I changed it, other than this is an integer, this is an integer. Why am I doing it float, right? So this would give me the same behavior, but now we saved on a lot of memory. Like a lot of memory. Right? Same exact thing. We just now, instead of storing 4 variables, we're storing only 2 variables for every single tile. Can we do anything else? ID, we need the ID. ID is extremely important. Wait, am I even using the ID? Oh, I will need the ID later on. Okay, I will need the ID. I'm not using it now. I will need it later on. Okay. So these are all the IDs. This is texture. All right, that's it. This is my tile. One thing that's redundant is the texture. The texture is redundant because I know that all the tiles are using the same texture. So every tile storing the texture, this is 8 bytes. Like 8 bytes of data, which is, I mean, it's not much, but if you multiply it by 288 tiles, that is now a substantial amount of number, big number. So why am I storing the texture? Do I really need the texture? I can just store, I don't need texture. This is unnecessary. This is unnecessary because I already know the texture is over here. So all I need is really the ID and the position. Okay. So all I need is this. This is my actual map. And should now we saved on a lot of memory. Substantial amount of memory. Which is good. I mean, not that substantial, but we saved on memory. Right? And there, we drew a part of our map using this array over here. Right? So now, this will be saved in a text file. This array will be saved in a text file, and I can load a map from a file. And we'll do that next time. So next time, we'll save this in a file and load it from a file. When we load it from a file, that's when we're going to need this ID. Because for every tile, we have an ID, and that ID will be stored in the text file. So we don't need it now, but next time we'll need it. And this is just my map. This is my map sprite. This is just call it map. Or just keep it map sprite. It's just 6 of them, right? And for every single, I just loop through that map, figure out the index, right? Figure out what the number this is, 120. What does it represent? Well, I know that 120 120 is the tiles at index 120. Give me that position, please. Right? So this is just the lookup table for that. There you go. That's that. Can I optimize this a bit more? I'm thinking, hold on. I'm thinking if I can make this better. Because I have a lookup table here. Do I even need the lookup table altogether? Hmm. Hmm. Do I need the lookup table? I don't think I need the lookup table. Because what I can do instead is say the lookup table is nice. If I don't use the lookup table, then for every tile I have to. Yeah, no, I need the lookup table. No, I do need the lookup table. It'll speed up things a lot. I was thinking what I could do is have a third loop inside. So it'll be 3 loops. The inner loop, what we will do is we'll go from one tile to the other and figure out that tile position. Hmm. Okay. No, I think this is good. Alright, this is not the greatest code so far, not the cleanest code. What is your problem? Buffer overrun while writing to tiles. The variable size is unsigned in 16, but 24 bytes might be written. Oh, because what is ID? ID is int. This is int. The fuck is your problem? Is it because this is size t? Would you be happy if I mark this as an int? What did I do? No, it's still unhappy. Buffer overrun while writing to tiles. Why is it buffer overrun? What? I don't. The variable size is unsigned, but 24 bytes might be written. How can 25? I don't understand. Why? I don't understand why you're mad. I don't get this error message. Well, it's a warning, not an error message, first of all. Let me rebuild this entire thing. Okay, there's a bunch of warnings. I try to fix all the warnings that I have, but I can't be bothered. Warnings are not an issue. But there's some warnings that say there's some data loss because this is requiring a double and I'm passing. Wait, how's that an issue? Update takes a double. No? Oh, it takes a float. Ooh. Okay. So yeah, there's a bunch of data loss. I was warning you because it's taking a double and converting back to a float. Yeah, why is this a float? Why isn't it a double everywhere? That's a very good question. Why isn't this a double? Because we want as much precision as possible. Like, well, I mean, it's double here. Let's fix it everywhere. So I can get rid of these warning messages. I loathe warning messages. Messages. Yes, I loathe warning messages. Warning messages are the worst thing in the world. A lot of people don't care about warning messages. I do. I like to keep my code as clean as humanly possible. So we had 11 warnings. Now we have only 6, 8. Okay, we only have 8. All right, what's your problem? Size_t to t possible data loss. Where's the possible? This is size_t. Fine, we'll make this as an int. Will you be happy if this is an int? Will the warning go away? We had 8 warnings. Now we have Only 7. Okay, what about you? Int, everything's int. How could there be sub warning? How could be there data loss? They're all ints. Oh, because this is a float. Oh, this is so stupid. You know what? Fuck you. Because this is dumb. Like, what do you want? What do you want? This is dumb. Okay. So these error messages are stupid. What about this one? Some of them are valid. Some of them are stupid. Float timer, we can fix that. The fire rate timer, we can make this a double rather than a float. Right? That'll remove one warning. Oh, hold on. We have a bunch of errors now. What do I do? Wait, what? What did I do? Binary, no multiplication left hand. Is this because this is a double? You are kidding. You are joking, right? You are actually joking me. Or kidding me. Okay. The problem here is that okay, the problem is delta time is a double, but when I do multiplication, SFML is not gonna happy. SFML wants this to be in a float, and so I can cast this. And I don't know if I talked about casting. Essentially, I'm taking this double and I'm casting it to a float, so the multiplication can happen. It's happy. This is fucking retarded. Okay. Oh, you're kidding me. I have to do this now everywhere. Okay, I understand why I made this a double now. Float. I'm regretting changing this now. I'm actually regretting changing this now. We're going to a float. I don't care. We're not doing this. We are so not doing this. Oh, but this looks so ugly with a float. But casting it every single time looks really ugly too. No, we're keeping this double. Okay, look, we have to keep this double. That's the stuff. Whatever. Objectively, I think this is worse code. Anyways. Timer is a float. Where's timer? This should be a double. Rebuild this. Just some code cleanup, ladies and gentlemen. That's all. Alright, this is that. It's complaining. You are still complaining about this, which I don't know how to fix. I'm sorry, I can't help you. Data loss. I understand there's data loss. This is. I can't help you here. Returning address of local variable or temporary. Returning address of local variable or temporary. This should be fine. You shouldn't be too mad about this. Anyways, okay, so we fixed, well, as many errors or warnings as I could. The other ones are fucking stupid. All right, so there you go. Anyways, this is the game so far. We're rendering a map. We're shooting in a specific direction. It's good. There you go. We have all that. I hope this, because there was a lot. There was a lot of stuff that I covered today, right? I hope all this made sense. If it did not, just remember that this is our actual map. There's just a bunch of index numbers. This is just our actual sprites that we're gonna draw on the screen. Here we're constructing a lookup table from our map over here. So every single tile over here has an ID and has a position, and we're saving this into an array of tiles so it can look it up later on. And this part is the actual map that I'm drawing on the screen. So in here, I'm just looping through this number array. I'm trying to figure out what the number 120 means. And according to that number 120, I'm rendering that specific tile, which has an ID of 120. I'm getting its position and y and x and y. And I'm setting the width and height, setting the scale, and setting its position on the screen. So this is the part where I actually set up the map, prepared the map to be rendered. This part is only for lookup table. This is where I do my rendering. That's it. That's all that is. Simple enough, I hope. Go through the video and like think of the math yourself. It's really important if you don't understand it. But there you go. This is all working. It's cool and pretty, and it's functional. So next time, what I'm gonna do next time is save this array over here. This is not gonna be hard coded in my class. This array over here is gonna be saved inside a file. I'm gonna load this array. So eventually we're just gonna have this, just the map sprites over here. So we're gonna load this file, and according to the file, we're gonna render the correct tile on the screen. All right? And then after that, we'll make the editor to generate my map. So I can place tiles and kind of save it to a file. Right? That's it. That's all. Hope that made sense. Hope everyone enjoyed, and I will let me push the code. No, hold on. I always forget to push the code. Let me push the code online. All right, so what changes did we make? We made a lot of changes. Bullet. All delta time is now a double rather than float. Created a lookup tile table for the map, rendered a map to the screen according to the array of numbers yeah, that's it. Push. Created map lookup table from tilesheet. Push that to dev, and there you go. Alright guys, I hope you had fun, hope you enjoyed, hope all that made sense. Do me a favor, press that lovely red button that says subscribe, and hit that lovely like button, and I'll see you guys hopefully, maybe not tomorrow, but we'll see. We'll see when I'll see you guys. Alright, take care. See ya.